I'd like to start the lesson with this warm-up problem. Try to reason through the answers. Press pause on your video when you're ready for the answers, and for me to explain them, press play again. Here are my answers. Notice that I'm given that there's a relative minimum at x equals 11 and a relative maximum at x equals 20. So the period has to be double that because my curve has to start and then stop in the same place. So my period would be the 20 minus 11 multiplied by 2, 18. For part B, we're going to use symmetry to solve. So if f of 22 is 0.766, that happens right here, 2 to the right of that relative maximum. So I know that there's going to be another value that gives me the same y, 2 to the left of that relative maximum. Once I have these two values, I can add and subtract the period to find as many other values as I want, because you can notice here that I'm going to have solutions anytime my graph intersects this horizontal line. So if I take each of those and subtract the period, it will land here and here, or I could add it and it'll be at the next hump. Now it says find the next three values of x such that f of x is 0.766. So therefore I want the next values, not the previous. So I'm going to take each of those values, 18 and 22, and add my period. They also will be 36 and 40. Those x values will also give you 0.766. Then to get a third after this 22, I would add 18 again, and you'll find that the next one after that is 54. So the next three values after 22 that will give you this y is 36, 40, and 54. So up until this point, we have been writing a graph from an equation. Now I'd like to write the equation from the graph. And really for these problems, I can write them as either sines or cosines, depending upon what my shift is. So if you can, let's write this one as a cosine. I'll write it as a sine in a minute. Really, what I want to do is fill in the blanks. So in looking at this, I can see that the x-axis has shifted down 3. So that means my d value is -3. Then looking at it, I can see my maximum, my relative maximum is 2 above that, and the relative minimum is 2 below that. So my A is going to be 2. That's my amplitude. Then, as far as the B goes, remember the B is what controls stretching and shrinking of the period. To find the B, I'm going to take 2 pi and divide by the period of my graph. Okay, so let's figure out what that is. So if my graph starts here, when I go 4 out, it's going to start repeating. So B will be 2 pi over 4, or pi over 2. And then finally, the C value is going to be the shift, right or left. I've got to remember what cosine looks like, since that's the kind of graph I'm writing it as. It starts above the x-axis, 1 amplitude above. And you can see that that point is here at the y-axis. So C is 0. I could also have a C value that is -4. Remember, -4 would shift it to the right. So I could write more than one equation with different values of C that would produce the same curve. So my equation would be, filling in the blanks, y equals 2 cosine of B, which would be pi over 2, x plus C, C is 0, so I'm looking at that, plus D. And that is the equation that goes with that graph. So the hardest part is finding that horizontal shift, that C value. And to do that, you need to know what your trig functions look like. You always are going to measure the shift from the y-axis. So if sine looks like this, I'm going to find that point that is at the x-axis and starting to come above and measure right or left from the y-axis. If it's to the right, C is negative. It's to the left, C is positive. For cosine, I'm going to look where my function is up in amplitude. For tangent, I'm going to look where my function crosses the x-axis. If it's reflected, it's going to look like these. I'm going to look on sine for where it's at the x-axis beginning to go down. For cosine, I'm going to look for a relative minimum. And for tangent, again, I'm going to look for where it's crossing this x-axis. But if tangent leans to the left, my A is going to be negative. If it leans to the right, my A is positive. For cosecant, secant, and cotangent, it's very similar. Picture that sine wave. You can measure from the sine wave, right and left. Picture the cosine, measure from the cosine, right and left. Look for where that amplitude is above the x-axis. Cotangent, it's going to lean to the left if it's not reflected, and you're going to look for where this first asymptote is, right or left from the first asymptote. If my A is negative, it means the cotangent curve is going to curve to the right or lean to the right, but I'm still measuring from where this left asymptote moves. Same idea with reflected sine and cosine as cosecant and secant. So let's try this one. Let's write one equation as a reflected sine, and the other is a reflected cosine. So thinking about what reflected sine looks like, it starts at the x-axis and goes down first. Reflected cosine starts down in amplitude, comes and wraps around. So again, our goal is to fill in the blanks. Let's start with the reflected sine. If it's a reflected sine, it means that my A value needs to be negative. And let's find each of these values. I know my D value is where that x-axis is shifted. So D in this case is going to be positive 3. So my A is negative, and I can see that my amplitude is 1. It stretches one above my x-axis and one below. So A in this case is going to be negative 1 since it's reflected. Then B, I've got to adjust for my period. Looking at this function, I can see that my period, if I look at where it starts to where it repeats again, it starts at negative 4. It's going to repeat once it gets to positive 4, so that period is 8. So I take 2 pi and I divide by 8. That gives me pi over 4. The next thing I want to do is find my C values. Since I'm graphing sine, I'm looking for where my function crosses the x-axis and begins to go downwards. So looking at that, you can see that one of my options is there. It's actually the only place that shows up on the graph. It'll also be here. So looking at that, it's 2 to the right, so C would be negative 2. And now at this point, all I have to do is write my equation. So y equals negative sine of B pi over 4 x minus 2 plus D. Now I have my sine function. I also would like to write it as a reflected cosine. Reflected cosine, everything's going to stay exactly the same except the shift. So I've got negative cosine pi over 4 x, and I'm going to leave that blank, plus 3. So for cosine, I'm looking for where my amplitude is down 1, where my graph starts down 1 amplitude from the x-axis. So looking at my function, that is going to happen here and here. And again, we're measuring from the y-axis. So here it is 4 to the left. That would give me c equals positive 4. And over here, it's 4 to the right, which would give me c equals negative 4. I can choose either of those. It will still produce the same curve. I'm going to put in a negative 4, but it also could have been a positive 4. Writing an equation for tangent cotangent really isn't much different. Now looking at this, if I write a non-reflected tangent, that means, remember, tangent curves to the right. It should look like this. It crosses at the middle of its period at the y-axis, or at the origin. So I'm going to measure from the origin to wherever that shift might be. So looking at this, let's write it as a non-reflected tangent first. And we're just going to identify what A, B, C, and D are. Now D is how much this has shifted up. And can you see it has shifted up 1. So my D value there is 1. How far up I go here and down I go there is my A value. So A is also 1. Then I have to look at the period. B is going to be equal to the period of my parent function, which is pi, over the period of my graph. Looking at this, my period goes between -1 to +3, so the period is 4. B is pi over 4, and then I've got to finally find C. Well, C is going to be how far did this point shift from the y-axis, and this has shifted 1 to the right, so C would be -1. So I can write this as y equals tangent of B, 1 times tangent of B, which is pi over 4, x minus 1 plus d. And that is my tangent function. Now I'd like you to take a minute and write an equation. It says non-reflected cotangent, but it actually has to be a reflected cotangent. Press pause on your video, and when you're ready to see the answer, press play again. Here are my answers for cotangent. You will notice that really A, B, and D are the same, except A is now negative since I have to draw it as reflected. Remember, cotangent usually curves and leans to the left. So it's reflected to look like a tangent curve. So A is -1. Then to measure the shift, I have to measure from the left asymptote of my period. So I could measure 1 to the left, which would make my C +1, or 3 to the right, which would make my C -3. So I could write my cotangent equation as either of these. It would produce the exact same curves. So there you have it. That is how you'd write an equation from a graph. The next thing I'd like to show you how to do is to find the domain and the range of your function without graphing. There's a couple trig functions I don't have written on here I'd like to add. So y equals tangent of x is not on here. The domain for that would be all reals except where there's an asymptote. So where x is not equal to, remember, tangent has an asymptote at pi over 2, and every time I go pi out from there. And then my range is -infinity to infinity. I also have y equals cotangent of x. My domain is all reals except where there's an asymptote. Remember, I have asymptotes for cotangent. It's 0, and every pi after that. So therefore, my domain will be all reals where x is not equal to k pi. The range will be from -infinity to infinity. So these will be the starting points for you to determine the domain and the range of your trig functions without first graphing. So let's think about what parameters affect domain and which affect range. Remember that anything on the outside of the function affects the range, affects my y values, my vertical. Anything inside my function affects the domain. So B and C will affect my domain. A and D will affect my range. So to the y values, what ends up happening is you multiply by A and you add D. To the domain, what happens is you divide by B and you subtract C. So let's find the domain and the range of this secant function. So first I'm going to identify what A, B, C, and D are. So A is negative 3, B is pi over 2, C is negative 1, and D is 4. So as far as what's happening horizontally, this is more than 1, so it's going to shrink my graph horizontally. That'll affect my domain. And it's going to shift my graph 1 to the left. That also affects my domain. A is negative 3. That's going to stretch and reflect my graph. And D is equal to 4. That is going to shift my graph up 4. And I think I should have said this is going to be vertically. So let's start with our starting points for secant. And what we need to do here is adjust where these asymptotes are, because the domain is all reals, but the asymptotes are going to move around based upon how much things have shrunk or stretched and which way things have shifted. So remember, we always divide by B and subtract C. So I'm going to take this asymptote and I'm going to divide it by B. And B is pi over 2, so that's like multiplying by the reciprocal. So let's simplify that. That would become 1 plus 2k. So right now, after we have shrunk it, now my asymptotes will be at 1 plus every 2 I go out from there. The next thing that happens is I need to shift my graph 1 to the right. So the next thing that I'm going to do is take these asymptotes and subtract C, which is really adding 1 because I'm subtracting a negative. So x is not equal to 2 plus 2k. So my domain is going to be all reals where there's not an asymptote. X is not equal to 2 plus 2k. Now, notice something. This 2 is 2 away from 0. Every time I go out 2 away, forward or backwards, I'm going to get another asymptote. If you want to write it like this, that's fine, because k is an integer. I can also write it like this. These are, they mean the same thing. If I put the set of integers in for k, I get all the same asymptotes. So this would be the domain for this function. Next, I would like to determine the range. So what affects the range? A and D. So first we've got to take this range and stretch it. It also reflects it, but when it reflects it really doesn't change where the range is. So we're just going to take this and multiply by the absolute value of A. So multiplying by 3, it takes these takes these minimums and maximums and pulls them away from the x-axis by multiplying by the absolute value of A. The next thing I have to do is shift it up 4. To do that, I have to add D or add 4. Negative infinity plus 4 is still negative infinity. When I add 4 to negative 3, I get 1. And then add 4 to 3, that's 7 to infinity. So my domain is this. I'd prefer that, but I'd take either. And my range is this. Now I'd like you to find the domain and the range of this one without graphing. Press pause on your video. When you're ready for the answer, press play again. Here is my answer. Notice that my starting place is different. So for cosecant, it's all reals where x is not equal to k pi. That is where my asymptotes are before I stretch or shift. My range is from negative infinity to negative 1, 1 to infinity. So I take these asymptotes, I divide by b, so I shrink them towards my y-axis by dividing by 2, and then I have to shift my asymptotes 2 pi to the right. So I'm going to subtract a negative 2 pi, which is adding 2 pi. So now for my domain, I could have written it like this. All reals where x is not equal to 2 pi plus k pi over 2. But I want you to notice something. 2 pi is a multiple of pi over 2. So since I'm adding and subtracting it, eventually I'm going to have an asymptote at 0. So I can skip all this and just write it as x is not equal to k pi over 2. Again, regardless of whether you write it like this or like this, I will mark it correct. The range starts here. I multiply by the absolute value of a, which is multiplying by a third, and then I add d. I shift everything down 1, and this is where it ends. So now you know how to write the equation from a graph and also how to find the domain and the range without graphing. Have a great day.